All right. Hello, hello, hello. It's finally time. We've covered all of the basics for predicting products. At this point, really all that's left is figuring out, well, how do I know what kind of reaction I'm looking at? And that's what we're going to be focusing on today. Okay, so there are ultimately 4 kinds of reactions that we've been going through. Technically 3, but there's 2 subtypes of one, so I'm going to call it 4. Double replacement, combustion, cation replacement, and anion replacement. Okay, now you should already have this worksheet. Okay, if you do not have worksheet, geez, I can't even read that. 5.3, this says E, but I think that's supposed to be a C. But if you don't have this worksheet already, it's got 4 and then another 14. You need to go get this, but pause this while that gets passed out, because you're supposed to have this while you're working through it. If it didn't get printed ahead of time, you can pull it up on the computer to see it, because I redid it last night, so that you should have access to it. Yeah. All right, so the first 4 are the 4 that we're going to go through while I show you kind of what you need to be looking for. And then after that, I'm going to cut you loose for the other 14. This should be pretty easy. Yeah, so let's just go. I'm going to start with double replacement, because double replacement is really, really easy to identify. Double replacement has 2 compounds. Both kinds of single replacement and combustion are always an elemental and a compound, but double replacement is always going to be just 2 compounds as the reactants. So, looking at these, which one, this is A, B, C, and D, which one is 2 compounds? Did you find it? Did you figure it out? I'm playing with my markers because I'm trying to open them all one-handed. It's B. B is 2 compounds. So B has to be double replacement. So we can just predict the products here the same way that we always would, or the same way that we would for double replacement. So we have cation, cation. So we're just going to transfer those over, CO and K. And then we have an anion in each compound as well, NO3 and MnO4. But we have to swap them, so since CO was bonded with NO3, the NO3 goes with K. And since MnO4 was bonded with K, it now goes with Cl. And then, of course, as always, we need to charge balance those products. So we need to figure out what the charges are for everything. Well, CO is annoying. We have to figure out what its charge is. We do that by looking at what it was. Well, this is -1. There are 2 of them. So this, since there's only 1, must be +2. So the cobalt is +2. Permanganate is a polyatomic ion, so you look that up and you find that it is -1. So we need parentheses and 2 for this one. For the other product, K is group 1. It's an alkali metal, so that is +1. Nitrate is another polyatomic ion. You look that up on your periodic table. It's -1, so this one is already charge balanced. Now, here's the follow-up, something else I want you doing on this worksheet. I want you to balance these reactions. And I'm going to review that with you. The reason I want you to do that is because you're going to have to do that on the exam for this unit. Because, I mean, it's pretty easy. You should know how to do it or remember. So you've got 14 practice problems here to make sure you remember how to do it. So the first step is to find the largest, most complicated molecule. And in this case, that's going to be cobalt permanganate, cobalt-2 permanganate here. So we're going to assume that this is a 1 and move forward from that. Now, a neat trick, now that you guys know your polyatomic ions, rather than charge balancing elements, we can actually charge balance ions, and this gets way easier. So I'm going to pick cobalt. Or no, I'm not going to pick cobalt. I'm going to pick permanganate. We're going to balance permanganate on both sides. There is 2 permanganates on the product side, and on the reactant side, there's only 1. Right? There's only 1 permanganate over here. So we need a 2 here. Now that permanganate is bonded to a potassium, so we can go back to the product side. Well, this potassium, there's only 1 here, so we need a 2. That potassium's attached to nitrate. Come back over, nitrate. Oh, there's 2 here, so this coefficient is just going to be a 1. And that is now balanced. 1, 2, 1, 2. Now, it is a pretty good indicator, by the way. If you cannot get your equation to balance, that your products might be wrong. Okay, if you're getting 20s and 30s and you're like, this isn't balancing, unless it's a combustion reaction. If you're getting really big numbers and you can't get it to balance, and you've restarted 2 or 3 times, you might want to double check your products, because you might have missed a charge balancing subscript somewhere, and that's what's throwing you off. Okay, so something to keep in mind. So that's the first one, double replacement. Okay, the rest all have 1 compound and 1 elemental. Here we have aluminum phosphate and hydrogen. Here we have that and oxygen. Here's oxygen again, and KCl. We're going to start, or we're going to next cover combustion, because combustion is the next. I should do single replacement. Yeah, we're going to do combustion first. Okay, because combustion's the next easiest to identify, but it's also mildly confusing. It's easy to confuse a combustion reaction with an anion replacement. And I want to talk about why. Okay, anion replacements, you have an elemental that is a non-metal. Okay, combustion, the elemental must specifically be oxygen, which is a non-metal. So that means that it's very easy to have those get swapped when you're looking at it, to mistake or misidentify a anion replacement or a combustion reaction as an anion replacement. Okay, so the tip, the trigger, the thing that you need to go on, every time the elemental is oxygen, you need to go stop, pause, wait a second. This could be a combustion reaction. Doesn't have to be single replacement. Oxygen gas as a reactant means this could be combustion. So, you look at the other reactant. Look at the compound. If the compound is an organic, that means that it's a combustion reaction. Now, what is organic? We talked about this in the last video. Organic means carbon and hydrogen. Maybe oxygen as well in that compound, but it has to have carbon and hydrogen. If the reactants are oxygen gas and an organic compound, carbon and hydrogen, then that is a combustion reaction. So, looking here, reaction A cannot be combustion because the elemental is hydrogen. It's not oxygen. So we don't have to worry about that one. Okay, if we come down to this one, we have oxygen. In fact, both of these have oxygen. So we need to look at the other reactant, the compound. Here we have C3H8O. Here we have KCl. Well, that's organic. That's carbon and oxygen, and maybe oxygen. Carbon and hydrogen, and maybe oxygen. I feel like I misspoke. Carbon, hydrogen, and maybe oxygen. Okay, these two mean this has to be a combustion reaction. Okay, and combustion reaction products are really, really easy because the products for combustion are just always, without fail, CO2 and H2O. So, since this is an organic and this is oxygen, we can just go straight to the products and go CO2, H2O. Now we just have to balance it. Now, if you don't remember how to balance combustion, which I would understand because it was the only one that was kind of mildly confusing, start with carbon. There are 3 carbons on the reactant side. We are going to assume that this is going to be a 1. That means that there's 3 carbons. So, over here, we need 3 carbons. Well, there's only 1 by default, so we're going to add a 3 here. And we're going to note the fact that that gives us 6 oxygens. We're not going to do anything with that right now. We're just going to note 3 carbons. Our carbons are now balanced. Now we need to do hydrogen. Well, hydrogen, there's 8 over here. Whatever we put here has to be multiplied by 2. So we're going to put a 4, and that gives us 4 oxygens. Cool. Well, our hydrogens and carbons are now balanced. We need to look at our oxygen. Well, we have 10 oxygens on the product side. So if we put a 5 here, we're good to go, right? No, not quite. There is an oxygen right there. It's annoying when this happens, but there's an oxygen right there. So if we put a 5 here, we're going to get 11. If we put a 4 here, we're going to get 9. We can't get that. We can't put a decimal here. What we really need here is a 4.5, but we can't do that. So we have to double. Oh, I dropped my marker. Yeah. We have to double our coefficients on everything that we've written so far. So instead of a 1, this is a 2. Instead of a 3, this is now a 6, which makes this 12 oxygens. Instead of a 4, this is now an 8, which means we have 8 oxygens. Now we want 20, but now there's 2 here, not just 1, because there's a 2 here. So 1 times 2 is 2. So we have 2 oxygens here. So then to get a total of 20, if we put a 9 here, that'll give us our 18. So a 9 will be our balance. 2, where is it? 2, 9, 6, and 8 is our balanced. And that brings us to single replacement. Telling the difference between eliminate organic or eliminate combustion as a possibility first. And then at that point, it's just, well, is it a nonmetal or is it an anion or is it a cation? So here, looking at the elemental, hydrogen has to form a cation. You know that because you memorized that. Hydrogen has to form a cation. So that means this has to be a cation replacement. So the aluminum and the hydrogen are what are going to swap places. So we're going to just transfer here aluminum and H without the 2 because H2 is not a polyatomic ion. And then phosphate, our anion, needs to swap from aluminum to hydrogen. So PO4 goes over here. Now, PO4, phosphate, has a charge of -3. Hydrogen has a charge of +1. So we need a 3 here to balance, or to charge balance. And if you don't do that, this is not going to be an easy thing to balance. Okay, now we need to balance the reaction. This is not a combustion, so we want to find the largest one. That's going to be H3PO4. And I'm going to tell you, in this case, you want to start with hydrogen. In single replacements, you usually want to start with the elemental when you're trying to balance. Okay, over here, we have 3, and here we have 2. Okay, when that happens, Just like when we swap them and drop them for subscripts, when we're charge balancing, we can do the same thing with our coefficients. So since we have 2 here and 3 here, there's no whole number we can put here that's going to give us 2, or going to give us 3. There's no whole number we can put here that's going to give us 2. So we want to try to get 6 on both sides. So we're going to put a 2 here and a 3 here. Okay, that fixes our hydrogen. Now we can go to the phosphate. So we have 2 phosphates on this side. So when we come over here, we need 2 phosphates. So we're going to put a 2 as the coefficient. That 2 doesn't just apply to the phosphate, but the aluminum. And aluminum is a metal, so it doesn't get a subscript. We have to put a 2 coefficient. And that leaves us with our last one, compound elemental. Elemental is oxygen, so red flag, could be combustion. But it's not, because this is not organic. So this is an anion replacement. So our one cation is going to be the potassium. So we'll just bring it straight over. Then we have chlorine, and oxygen, which have to swap places. So we're going to put the chlorine over here and the oxygen over here. We are not bringing the 2 because that 2 is not part of a polyatomic ion. Chlorine is a diatomic, so it actually needs to gain a 2. And if you don't do that before you start balancing, this is going to be interesting. Potassium is a positive 1. Oxide is a negative 2, so we need 2 potassiums, so K2O. And now we can balance. Now in this case, actually, yeah, there is still technically one that's larger. This is larger. So we can pick either the oxygen or the potassium. I already told you. Were you listening? Wait. Yeah. Whenever you have a single replacement, you always want to try to balance that elemental first. So we're going to do the oxygen first. Well, there are 2 oxygens on this side and only 1 here, so we need a 2 here. That 2 affects the potassium as well, so coming over here, there's 4, so we need to write a 4. That 4 also applies to the chlorine. We need 4 chlorines, but there's 2 here. There's 2. So that means we need a 2, because 2 times 2 will give us 4. And then this stays a 1. And that's it. That is it. That's all there is to it. So in quick summary, the things you look for, you go in this order to eliminate. Double replacement. Is it double replacement? Is it combustion? If it's not double replacement, is it combustion? And then is it an anion replacement or a cation replacement? Okay. Double replacement is going to always be 2 compounds. Okay, 2 formulas with multiple elements in it. Okay, then is it combustion? Well, your red flag on combustion is the elemental oxygen. If it is, then look at the compound. Is the compound organic? What makes a compound organic? Carbon, hydrogen. Okay, and then the products have to be carbon dioxide and water. And then you have your last one, the last 2 actually, are cation replacement or anion replacement. If the elemental, let's switch fingers here so I can do this. If the elemental is a metal or hydrogen, it's a cation replacement. If the elemental is a non-metal, then it has to be an anion replacement. That's how you identify them. And then, of course, balancing is still the same as ever. This video was a little longer than I hoped it would be, but hopefully this was clear so you guys understand what is going on. Have a wonderful day, night, afternoon, evening, whatever time of day it happens to be when you're watching this, and I will see y'all in the next video. By the way, one last thing. At this point, you're ready for a quiz. So, yeah. Quiz probably at the end of the week. Or in 2 days. I don't know when this is actually coming out. So, yeah, have a wonderful night.